The acute angle between the vectors is denoted by theta. Find cosine of theta. To find the angle between two vectors, we use a dot product, and it is given in a data booklet. The dot product of two vectors is equal to x1, x2 plus y1, y2 plus z1, z2, where x, y, z are coordinates of the corresponding vector, and it is also equal to the product of the magnitudes of these vectors and the cosine of the angle between them. So we consider this, and hence we can get equation with respect to cosine theta and cosine, and then theta can be found. So what is x1 times x2? It's just 3 times 5 plus negative 4 times negative 4 plus negative 5 times 3 is equal to the magnitude of a vector, its length, it's a square root of the sum of squares of its coordinates. So for the first vector, it's 3 squared plus negative 4 squared, or just 4 squared. It doesn't matter because squared is positive, plus 5 squared e multiplied by square root of 5 squared plus 4 squared plus 3 squared, and multiplied by the cosine of the angle between them. And let's just calculate it. So we get 16 here, and we can see that these expressions are equal, so it will be 9 plus 16 plus 25, so it's 50 cosine theta, and hence cosine theta is 16 over 50, or 8 over 25. We can see that cosine is positive, hence theta is acute angle. And if question is to find the angle between two lines which intersect, we can see the direction vectors of the lines as two vectors, and absolutely similarly do the same, and we can calculate cosine. If we get cosine is positive, hence we get acute angle between two lines. But if we get cosine is negative, it means it looks like this: angle between two vectors is obtuse, greater than 90 and less than 180. And we know that when two lines intersect, there are two angles. One is acute, another is obtuse, and they add up to 180. So if we know one angle, and if it's obtuse, another which is acute can be calculated as 180 minus obtuse angle if acute angle is required, but calculated angle is obtuse. And that's all for this question.